to my computer and I'm sharing my screen again. So today's session is about the obstacle avoidance robot. Okay, so we will be doing the assembly and I will be explaining what is this ultrasonic sensor and how it works. Okay, so do you have Quarky with you, ma'am?
Yes, sir.
Okay, so what is an obstacle avoidance robot? What does name mean, or what you are getting from the name?
Sorry, I have no idea about that, sir.
Okay, so it's simply a robot which is moving on the ground or on the road, and it's continuously sensing the front view. Okay,
Yes,
and
sir.
if there is an object in between its path or in the field of view, then it will read the distance and take a left or a right to avoid that obstacle.
Yes, sir.
Okay, it will continuously scan a range of 0 degree to 180 degree. I mean, the whole front view, the robot will scan, and if there is an obstacle in front of its path or in the field of view or in the frame, and it will detect the object and take a different path to avoid that obstacle. And all if all the paths are closed, and means if all the paths have some object or obstacle there, then it will move back.
Yes, sir.
So today's session, we will be covering the assembly and we will be covering how we can connect ultrasonic sensor with this Quarky robot and how we will be able to read the distances. Okay.
Yes, sir.
So you have Quarky robot with you, na?
Yes, sir.
I request you to please take a screwdriver and all the blue color parts with ultrasonic sensor packet.
Yes, sir.
Okay. And here is an overview how this robot will work. PIF will shows is showing that if there is an obstacle like the box or any other obstacle is in the path in the way, so it will directly take a different route and move back or move in a different direction.
Yes, sir.
So I'm covering the assembly first. So this robot you are having na.
Yes, sir.
Okay, then remove the unscrew the this screws to remove this caster wheel, then use this plate, I think this is B4, to assemble
Yes,
the servo motor, to fix the servo motor.
yes, sir.
B4 plate it is, ma'am.
Yes, sir.
B4, B2, and B7. And one servo motor is required. Where are you located, ma'am?
Latur city, sir.
And which state?
Maharashtra.
Okay, you are from Maharashtra.
Yes, sir.
Okay.
Then, sir. So done.
While assembling the this blue color plate, na B4 plate, you
Yes,
have
sir.
to make sure that name must be on upper side.
Yes, sir. E4. Done, sir.
Okay, this assembly is done.
Yes, sir.
The blue color plate you have fixed.
Yes, sir.
Servo motor.
Yes, sir.
Okay, great. Okay, okay, you have fixed the servo motor. And do you know how to connect servo motor with this quark key?
Yes, sir.
Okay, then connect the servo motor with quark key.
Yes, sir. Actually, I'm taking a practicals on kit. That's why I already connected these all parts.
Okay, you have already connected.
Yes.
Okay, then you must be aware how to use ultrasonic sensor and everything.
Yes, yes, yes.
Great, ma'am. One another person has joined the meeting, na? Hello, hello, sir, ma'am, who have joined just in between the session. Hello, Yashodha, Yadav, sir, or ma'am, I don't know.
Yes, sir. Yes. Hello, sir. Good morning, sir. I have class, sir. So while attending class only today, I had to, because we have full day today, sir.
Okay, you are occupied?
So I can't do that practical. I have class, sir. While teaching only, I have to attend this practical, sir, today.
Oh, okay, ma'am. Okay, okay.
Okay, sir. The children are with me only.
Mm-hmm.
So
So you are teaching the different thing to students
yeah,
right
yeah, yeah.
now?
Computer subject. Now I am not teaching AI, sir.
Okay.
Computer classes, sir. We have to complete the portion also, sir. So
And okay, so you are doing the other thing and you are joined just the session, na?
yeah, yeah, yeah. Just because now just a short break was there. So
Mm-hmm.
just I immediately I joined the class, sir.
Okay, ma'am. Okay, chalega.
But I will just follow these recordings, no, sir.
Mm-hmm.
Yeah, yeah, I will do it, sir, because I did this all, but also I will be attentive in this, sir. No problem.
Okay, ma'am.
I'll
Okay, okay.
follow this recording, sir.
Sure, ma'am.
Okay, sir.
Hmm. Hi, ma'am. Is it done?
Yes, sir.
Okay. Now let's move ahead. Uh, I request you to please set the servo motor to 90-degree angle so that just like we are having our face in the forward direction and in the front, in the same way when we are moving our robot, na, we will be doing the assembling and doing the coding. So whenever we are running the script, our robot must initially look in the front direction or it must be aligned in the forward direction only. So you have to set the servo motor to 90-degree angle. Ma'am, how servo motor is different from other motors? I'm just asking, ma'am, just to talk.
Actually, sir, servo motor is rotating 360 degree, I think.
Mhm.
180 degree.
Uh,
Is it right,
so
sir?
both the one which is having the tire fixed on Quarky, right? It's a motor, and servo motor is a different and one another motor, right? So
Yes.
what is the difference between these two? If both are the motors, so what is the difference between two? I mean,
Servo motor and another motor.
yes. Hmm. The one which is having the tire, na, is a DC motor with gear, or you can say simply a DC motor. So whenever you are connecting it to the supply, na, so it's continuously converting electrical energy into the mechanical energy, means it's continuously starts rotating.
Yes.
Okay. And when you are connecting the servo motor, na, you must have seen that it's having three wires, red, brown, and orange or yellow. So the red wire is plus, the brown wire is the or brown or gray wire is the negative wire, and the yellow or orange wire is the signal pin. It's also called the PWM pin. So whenever you are giving some command from the computer, na, for example, say 30 degree, a pulse is generated which will travel from your quad key through this PWM pin or signal wire from quad key to the servo motor. And there is a small controller, you can say, or a regulator inside the servo motor, which reads that signal, that value, and inside the servo motor there is a small variable resistor, or you can say a potentiometer, which changes its resistance and moves the servo motor to a desired value. Okay, whenever the servo uh, reaches that particular value, the potentiometer resets itself, and the motor will remain to that location only. If you are sending or trying to move the servo motor, for example, you have set a command, set servo to 30 degree, and you are using the forever loop, the servo motor will move only for the first time to 30 degree and remain there and remain stick there forever, because it's already aligned to 30 degree. And whenever you are sending to move 30 degree, servo motors, like, it's calculating where I am right now and where I'm supposed to go. So it's saying that, okay, I'm supposed to go to 30 degree and I'm already at 30 degree, so I'm not moving anywhere. So this way, if there is a change in the angle from previous value, na, the servo motor will move. Otherwise, if you are sending the fixed value in a forever loop or continuously, the servo motor will remain at a fixed location. Hmm. Okay. So you have also connected this sensor.
Yes, sir.
Okay,
But,
everything you have done.
sir, I didn't get how to set servo motor at 90 degree.
You don't know, or you have set
I,
already?
I know, sir.
Okay, okay.
Set servo motor 1 at 90-degree angle.
Yes.
Is it right, sir?
Yes, ma'am. And click on that block. If you have connected your quad key with the servo motor, na, quad
Yes,
key
sir.
with
Yes,
the
sir.
Pictoblox, click on that block, set servo to 90 degree, and then do this assembly, the sensor assembly.
I did Pictoblox program, sir. When flag click, and then second block is set servo motor.
Mhm. Can
Only
you
two
share your
blocks are there.
screen? Can you share your screen, ma'am?
Yes, sir.
Okay, if you can share your screen, I'm like, hmm. Okay. Yes, ma'am, it's correct. You can fix the sensor wala part.
Is it right, sir?
Yes, ma'am, it's correct. Your quad key is also connected via Bluetooth, and you can fix the sensor assembly.
Uh, Click on sensor. Then,
Hmm. Okay, so it's connected, na? Then go to sensors.
sir.
Go to sensors. This connect ultrasonic sensor one. Yes, this one.
First,
This block. Okay. This block is initializing the setting for our ultrasonic sensor, so that, like, Quarky has onboard sensors, right? IR sensor, touch sensors, and their pins are
yes.
already defined inside the Quarky firmware. So we are already having the options like read IR sensor 1 and IR sensor 2. So we are not supposed to define the pins. But whenever we are connecting the external devices to our Quarkina, in that case, we have to define the pins, because Quarky don't know where we are connecting the external devices. In
Yes.
our case, right now, in our case, we are having the ultrasonic sensor. So that's why we need to define the pins. We need to initialize the sensor. So that's why we are using this connect ultrasonic sensor one, echo and trigger pin.
Yes, sir.
Wait, I'm connecting my charger to the laptop.
Shall I stop sharing, sir?
You can continue, ma'am, sharing. I'm just like,
Okay. You tell me. I will follow your instructions.
yes, ma'am. So, do you know how ultrasonic sensor works?
It's passing some signals.
Okay. So, you are from electronic background or from computer?
I'm from electronic background, sir.
Okay, then you must be aware VCC ground and other, na? Okay. So now you can use this forever loop here.
Yes, sir. This one.
forever loop. Inside the forever loop, go to looks and add the say block.
See.
Under looks and say block. The second one. Yes. And now when you are starting the script now, this script will continuously say hello, but we are not interested in reading the hello. We are interested in reading the distances. So again, go to sensors.
Yes. Yes, sir.
Go to sensors and in the ultrasonic sensor section, the second block, get ultrasonic sensor distance. Now you are reading the distances and you will be able to show the distances in the output. Now run the script. Why you are reading the zero?
Yes, sir.
Make sure you have connected the, okay,
Yes, sir.
you got the values, no? You are
Yes.
using USB or Bluetooth?
Bluetooth, sir.
Okay, right now you are using the Bluetooth, no?
Yes.
Okay, just hold the sensor and the wire plug and remove and plug again wires. Sometimes the wires remains the loose.
Okay, sir.
Hmm. Red wire you have inserted to V connection, na?
No, sir. It's correct, but this IC was collapsed by
Which I see?
student. IC connections
Bluetooth port is
down, sir.
disconnected. Bluetooth port is disconnected. Your power key is not connected, ma'am.
Yes.
Hmm.
Sir,
Now you are,
it's working now.
yes, now you are getting the distances, na?
It's initialized servo motor, sir. But
Sorry?
servo motor is working.
Servo motor is already at 90 degree, na? So
Yes,
motor will
yes.
not be moving. It's fixed.
Yes, sir, now it's working, sir.
Okay. Okay. Now go to if controls. Use if then else block. If then else. Yes. Insert inside the forever loop. Correct. Go to operators. Use if distance. Sorry, less than operator. This one.
Yeah.
Use distance block. Get ultrasonic sensor distance. Set some value. For example, 20 centimeters or 30.
Yes, sir.
Here, type some value, 20, 30, whatever the value. Okay. Now go to display and show some warning. Maybe from the emotions, there is a reject option, or you can say the display matrix
Emotions.
as you can draw your custom
Yes.
patterns. Emotions. Under emotions, there is a reject block.
Is it right, sir? Hello.
Your screen is stuck, ma'am. Hello, ma'am, your screen is stuck. Hello, 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 ma'am.
Yes, sir.
Ma'am, your screen were stuck.
Actually, my connection was
Okay, it's okay, ma'am. It's okay, ma'am. Inside the if block where we have set the condition, na?
still.
Sorry.
Shall I screen share again?
Okay, it's okay. I'm sharing from my side.
Yes, sir. Yes, sir.
So what we have done, we have connected this. and we have initialized the sensor. We have set the servo motor to 90 degree using the set servo block, right?
Yes, sir.
And after that, we have used this forever block. We are reading the distances. Okay. And after this, we wanted to set some conditions on the distance. So I'm using this if else block. Inside the if else block, if distance is less than,
Excuse me, sir.
Hanji
Your
ma'am.
screen is not visible, sir.
Oh, I'm sorry, ma'am. I forget to share the screen, I think. Hmm. Is it visible now?
Yes, sir.
Okay. So inside the if block, we have used the less than operator, and inside the less than operator, I'm using this distance wala block. Till this point, you have completed, na?
Yes, sir.
Okay. If the distance is less than 50 centimeter, I'm changing it to 20 centimeter. If
Yes,
the distance is less than 20 centimeter, then go to this display palette and use the first block, display happy emotion. And here we are having this reject. This will display a cross on the Quarky screen. And if the distance is higher than 20 centimeters, then what we can do, we can show a green icon here, green display here means everything is okay, we can move. And what else we can do? Just test this script, ma'am.
yes, sir.
Test this script with your Quarky.
It's not running. Yes, sir. It's displaying green signal. Hello.
Is it showing cross and green?
Yes, sir.
Okay. This means we are reading the distances properly, and we can also apply the conditioning. We can also apply the logics.
Yes, sir.
Let's do the movement wala part here. Go to this robot palette and
Yes.
go to add this move forward with 100, change it to, for example, say 50% speed. If the distance is higher than 20 centimeter, and if the distance is less than 20 centimeter, we can add this stop block here. Now test this.
What's-
Is it working, ma'am?
Yes, sir.
Okay. So let's do a simple activity here. So just like we are having the robots, na, human following robots.
No, sir. I didn't have this human.
Sorry.
Don't have.
I'm just saying, I'm giving an example.
Yes, sir.
Okay. We are having some robots now which are following the humans are the objects. So we will be modifying our existing project, this obstacle avoiding robot. In the next section, you will be doing actual coding for the obstacle avoiding robot. This today's session was only about the assembly, but we are doing the extra thing. In the extra thing, I'm explaining you how we can do an activity. Uh, okay. Hi, ma'am. So in this activity, what I will be doing, I will be making our obstacle avoidance robot to follow us or to follow a human. So we will be showing the hand, and obstacle avoiding robot will follow us if we are within a defined range. And if the robot is supposed to hit us or any object, the robot will stop. And if we are out of the range, means we are not in the range of our robot or in the field of view, the robot will also stop. So our robot will only move if we are in the range. Okay.
Sir.
So removing this. I'm also removing these two blocks from here. I'm again adding if. I just need this block, these two blocks. Firstly, we need R operator here. So and operator, sorry, and operator. If distance is less than 20, sorry, I'm saying it to 10 centimeter, and if distance is greater than 50 centimeter. Okay. If distance is less than 10 centimeter, I want to stop my robot. And if distance is greater than 50 centimeters, means I am out of the range of my robot. So in that case, my robot will also stop. So to apply these ranges or these two things, I have to use this AND operator. So if the distance is less than 10 centimeter and if the distance is greater than 50 centimeter, if the distance lies in between these two values, if both the conditions are true, in that case, my robot must move in the forward direction at say 80% speed, for example. And if the distance is out of these range, if the distance is less than 10 centimeter, means the robot is about to hit an object or hit our hand or us. And if the distance is out uh, above or higher than 50 centimeter, means we are out of range. And if we are out of range, our robot will also stop here. Ma'am, please test this code in your Quark key. We can also add some custom patterns or emotions here or other things.
Just very fast.
Is it working, ma'am?
Actually, I'm doing this code, sir.
Firstly, use the AND operator, and inside the AND operator, you can add the range. So less than and greater than operator, and inside these operators, you can set the conditions for distance.
Yes, sir. Sir, it's working.
Okay, is it working?
Yes, sir.
You can also add other things like display or some emotions or custom patterns. If the distance is less, you can add the cross or any warning, or you can also play the sounds if you want. Other teacher who just have joined, if they want to ask something or if they want to ask about a session, they can ask. If you are having any query, they can also raise, please.
I think, sir, I don't have any query right now.
I'm sorry, ma'am, what you were saying?
In this session, I don't have any question.
Sorry, ma'am.
So I don't have any query.
Okay, you are not having any query. That's good. If any other teacher is having any query, they can please ask. Okay, so there is no query from your side. So I'm stop sharing my screen and I'm just concluding here. So today we did the assembly for this obstacle avoiding robot. We did the assembly, we connected the servo motor and ultrasonic sensor with the Quarky. We did some experiment with the sensor and we also applied some coding and different logics. And at the end, we created an human following robot, you can say, or in just hand following robot, whatever the name you can give to this robot. So with this, I'm concluding this session. If you're not having any query, any question,
Yes, sir.
then we can stop this session. Okay.
Yes, sir.